Hello student. Up to last lecture we are discuss about the mean, median, standard deviation and mode, and we see the two example of the temperature reading air and -4 feet ground. Today we are discussing about the data reduction and interpretation. Vibrating wire sensor and electrical resistance sensor. In vibrating wire sensor we have a piezometer and inclinometer. Then we have a electrical resistance sensor like a strain gauge. Today we are discussing mainly focus on the data reduction and interpretation. So first we are seeing that the what is the how piezometer calculate the pore water pressure and temperature correction. So first of the you can see this is first equation shows that the pore water pressure calculation, P is equal to R minus R naught into G, where what is the R naught? R naught is the initial reading of pressure. Then what is the R? R is a current reading and G is a calibrating factor. So we can calculate the pore water pressure by using the piezometer, by using this calculation. Because no any sensor gives the direct reading of pressure. Means ki if we have a sensor that measure the pressure, then it sends the some physical condition and gives the signal in form of any type signal it can give. So we are taking this signal and use by using the equation or any other form we are converting into the desired form. Means ki if we want to measure the pore water pressure, then we are converting into the pressure reading. Understand? Then temperature correction. How we are correcting this temperature? Because temperature affect the pressure, not that. If we have a temperature difference, or if we have a temperature variation, then we can have a different reading of water pressure. Then how we can correct this temperature? And then again we have a equation P is equal to R minus R naught into G plus PT. What is PT? PT is a temperature correction point. Or what is the equation of PT? PT is equal to T minus T naught into K, where T naught is the initial temperature, T is the current temperature, and K is the thermal factor. Then if we want to correct the temperature, then use this equation. Then inclinometer give the linear displacement. Then how can we calculate the displacement? Sensor cannot directly give the inclination or a linear displacement. It gives the some reading, or it gives some signal. By using the signal we are calculating our inclination. What is the equation? We have a equation delta theta is equal to delta sine theta is equal to R minus R naught into G, where R naught is the initial reading, R is a current reading, and a linear gauge factor. All are depend on this linear gauge factor. Then delta theta is equal to delta sine theta, valid when the angle is a small. This is the one of the assumption that we are taking, that delta theta is a delta sine theta, but when the angle is a small. Then how can we calculate the displacement? Displacement is calculated. See L1 in the figure, L1, L2, L3, and when it is displaced from its main place, we have another position of L1, L2, and L3. Then each linearity or sensor is a move from its original initial position. Then how can we calculate the displacement? We have a 3D reading of displacement D1, D2, and D3, because each point is displaced in a different reading. So D1 is a we are starting from the down. D1 is a L1 into delta sine theta 1, where we have a reading of theta 1 and L1. So we can calculate the D1. Then we have a already have a D1 reading. Then we can calculate the D2 by using the D1 plus L2 delta sine theta 2, where already we know the what is the value of D1. Then D3, what is the D3? D3 is an D2 plus L3 delta sine theta 3. So we know the all the values of D2 and D1. So we can put in the equation of D3 and we can find out the values. Then we have this is the calculation of inclinometer. Then we have another calculation of strain gauge. So how we can measure the strain or stress, ठीक है? तो we have a equation of strain is equal to GGF, general gauge factor, into V out upon V XCE, excitation voltage. So in strain gauge, we give the voltage excitation, and we measure the voltage output. So by dividing the voltage output by the voltage excitation, and then if we multiply it with the general gauge factor GGF, then we got the strain calculation. So you can see in graph, there are on the x-axis there is a transducer output in volts, and on the y-axis there is a strain in a micro E. So according to voltage output, we are mapped in the strain. See, if I miss something, and you find that I am missing something in an explanation or in an equation, then you can comment in the Facebook, because when I am recording my lecture, then sometimes I forgot to explain something like कोई like equation, या or any figure. Then kindly please comment in the comment section that I am forgetting this, then we are explaining again. But if you are not give the feedback, then how will I know that I am missing something in the video? Okay. Now we are discussing about the data interpretation. Up to now we are discuss about the how we can calculate the readings from the sensor output. Now we have a data, we have a readings. So how I can interpret this data? So in a piezometer, see, we have a date, and on the x-axis we have a date, and on the y-axis we have a pressure. So in the sensor gives the continuous reading. Then we can take the reading in a hour, or in the interval of 1 minute, 5 minute, 10 minute, 30 minutes. So every minute we can take the reading, and according to our need we can map into the graph, we can map into the graph, and we can observe this reading for our purpose. If a piezometer reading or a pressure is is more than the we expect, then we can take some action about the poor water pressure. So these are the data interpretation. So we can have we have this readings, and we have this graph, and continuously we are monitoring about this. And if we are able to write some codes, then we also can write some code that if reading is exceeds then certain limits, then we get a alert on a mobile, या फिर or any software, या फिर message. So we can get do that with the readings. This is also data interpretation of inclinometer. Here we have a reading of piezometer. Then here we have a reading about the horizontal displacement in millimeter. Then here we have a readings of temperature. Different reading we have in Celsius. So we can observe this reading, and if we find something wrong, then we can make a alert, or we can change some things that this temperature or any readings not harm our system. Then signal processing. We have a sensor data. We have a signals. Or if we want to see, or if we want to display this reading at any place, like mobile or like in a software, then we have to first convert these signals in a digital form. So for converting the signal to digital form, we use the time domain process, in which we have a discrete signals. Signals also have a noise, so we have to remove this noise before converting the digital signal. So digital detracting, moving kernels, stacking, and spike removal. So we can see the signal, discrete signal in a oscilloscope also. So here one or two definition about the continuous and discrete signals. What is the continuous signal and what is the discrete signal? The continuous signal is the caseless and the uninterrupted observation of parameter in the time or space. Means, what is the continuous signal? Continuous signal means it is happen every second. It gives the reading. Then these signals are the continuous signal, caseless or uninterrupted observation of parameter. In a mercury thermometer, it senses the temperature and gives the continuously reading. If you see the thermometer which have a mercury in it, then it will give a continuous reading. It will not give the reading like in 5 minute duration or in a 1 minute duration. Then we have a discrete signal. Discrete signal is a intermediate observation of the parameter, that is a sequence of values separated in a time or space. So these readings are not continuous. These readings are in a time, matlab in time duration. After a 1 minute, or after a 5 minute, after a 10 minute, after a one half of hour, 30 minute, or after a hour, after a 2 hour, after a day, after a 3 day, after a month. So these are the discrete signals which are separated in the time or a space. Temperature sensor records the temperature at a certain sampling interval. So if we are continuously measure the temperature and store, then we have a number of readings that we cannot observe, or we cannot use these readings in a proper manner. So we are discrete. We are taking a reading in a certain temperature, in a certain time interval, and use this reading for our purpose. Continuous and discrete signal. Here we have one of the continuous signal, and on the other side we have a discrete signal. Then in a continuous signal is a parameter of time. Equation is xt is equal to t square. Then this is the continuous signal. But if we have a equation like xi, matlab, in a interval of time, or in the interval of anything, then these are the discrete signals. Then we have a aliasing. So up to now we are ending over there, continuous and discrete signal. After, if you find any query, then comment in the comment section. Thank you.